This is 2017, question 5b. We have a smooth sphere P, another one Q. P and Q colliding obliquely. P, you can see, is going in this direction here at an angle alpha to the horizontal. So we have no other information other than the angle alpha. So we have u cos alpha in the I direction plus u sine alpha in the j direction for P, which we're told has a mass of 3m, collides obliquely with something Q at mass of 7m, which is at rest. 0I plus 0j. It's good to set up the I and the j when they're colliding obliquely. The I will change, so we have P in the I direction plus u sine alpha in the j direction for afterwards. And we have any information about Q after the collision. The speed of Q is v. Okay, so that will be v in the I direction plus maintaining the j 0 in the j direction, and we're given E to be 2/7. Find in terms of v and alpha the speed of P before the collision. Okay, well, let's set up our equations. Conservation of momentum, 3m by u cos alpha plus 7m by 0 is equal to 3mp plus 7mv. Dividing by m, we get 3u cos alpha is equal to 3p plus 7v. For Newton's experimental law, we're going to get p minus v over u cos alpha minus 0 is equal to minus E minus 2/7. So 7p minus 7v is equal to minus 2u cos alpha. We have a plus 7v above, so we can say 3p plus 7v is equal to 3u cos alpha. Solving these down, we're going to get 10p is equal to u cos alpha. So P is u cos alpha over 10, or a tenth of u cos alpha. Q, or V, actually we're dealing with V here. Do we have an equation for V? A simple one? We don't, so I'm going to have to say that 7V is equal to 3u cos alpha minus 3p. So that's 3u cos alpha minus 3u cos alpha over 10. So that's like 30 tenths minus 3 tenths, so that's 27 tenths. 27u cos alpha over 10 is equal to 7v. So v is equal to 27u cos alpha over 7 times 10, which is 70. So there are the speeds. Then we're asked, if alpha is 30, find the angle through which the motion of P is deflected as a result of the collision. Okay, with Pi plus u sine alpha j, so that's u cos alpha over 10. Plus u sine alpha, and alpha is 30. So if alpha is 30, we get u by the cos of 30, which is root 3/2, so that would be root 3/20. And then that's in the I direction, and u sine alpha will be u by 1/2, so that's just u/2. In the j, the tan of A is going to be the velocity in the y or j direction over the velocity in the x direction. So therefore we get the inverse tan, or the tan of A, is equal to u/2. That's what the u's will cancel, so it's 1/2 divided by root 3/20, which is is equal to 20 over 2 root 3, which is equal to 10 over root 3. So we get the inverse tan of 10 over root 3. The answer is 80.17 degrees. So let's have a look at our diagram. So it was coming in at an angle of 30, and it's now going in at an angle of, say, 80. This is 30. We got 80.17. It's been deflected 50.17 degrees.